Hello my dears, very good morning to all. So in the last class we discussed about what ABCD parameter or transmission parameters, right? So let's continue from that session itself. Okay, so see so what was our transmission parameter? Why the name T parameter or transmission parameter means? In transmission system, right, in our transmission line or transmission system, whenever we are dealing with power system, it is very clear to you. Okay, this is very important thing. This is very important. You have to find the transmission line parameters. Transmission line parameter, that is propagation constant gamma, like that, or propagation velocity of the signal, like many parameters are there. When we are dealing with the transmission system, it will be more and more clear to you. So there it is used, actually very much used there. That is why it is called the the combination of these things connected to the propagation constant equation or transmission line losses equation, etc, etc. Okay, so that's why, and regulation also, voltage regulation concept also can be connected with this ABCD parameter when we are dealing with power system. Okay, so let's study there. Okay, so now for our circuit theory base, just we have to know what is a transmission parameter is. Suppose some voltage and current V1 and I1. V1 is nothing but input voltage, I1 is nothing but the input current. This is connected by this system or this equation. Then we learn something. A is nothing but it is the ratio of input voltage to output voltage is no unit, and C is I1 by I2, and A and D no unit, B ohm, and C in MO, right? C in MO or ohm raised to -1. We learned that. And by looking these parameters A and D, that means by looking this matrix, ABCD matrix, we can predict the system is symmetry. The system is symmetry or not. If A equal to D, then system is symmetry. System is symmetry. What is the meaning, real meaning of symmetry? What is the, in your BTech and all, you simply studied A equal to D means symmetry and AD minus BC is equal to reciprocity. Okay, but what is the real meaning of symmetric network? What is a symmetric network? We will discuss now. A symmetric network means any network, any network. Suppose this is R1, this is C1, and this is R2, and this is C2, and again this is R, and some element will be there, like that. This circuit, it is like infinity tak or very long circuit is this, and in the other end, also, see, this is a symmetric network. How can we say it's a symmetric network? Means in the input side, 1 R, 1 C, similar manner in the output side also. That means the allocation of elements in a circuit, it may be very big circuit, it may be a very big circuit. The allocation of element in any circuit, a very big circuit, is symmetrical. Symmetrical means if you exactly cut the circuit at its central, what is the symmetry means? What is symmetry means? Similar, right? So if you exactly cut the circuit at any point, at middle point, then the left half will be exactly the mirror image of the right half. That is the meaning of a symmetrical circuit. So if A equal to D means, A is what is V1 by V2, and what is D here? D is nothing but I1 by I2. If V1 by V2 equal to I1 by I2, that is the meaning of A equal to D, If these two are equal, A equal to D, then we can say that the circuit is simply identical. It can be a mirror image. If you cut the circuit at middle of it, then it will be definitely one portion will be the mirror image of the other portion. That is the real meaning of symmetrical circuit. Is it clear? Is it clear? So if A equal to D, then we can say that it is symmetry. In one word question, no, some examination, one word question directly ask this, if what is the condition for symmetry by using ABCD parameter, A equal to D, A equal to B, B is equal to C, like that you will have some options. So A equal to D is the answer, A equal to D is the answer. Is it clear? And one more thing you have to see, reciprocity, or simply reciprocal or reciprocity, right? Reciprocity. You already learned this, no? What is the meaning of reciprocity? You already learned. What is the meaning of reciprocity? Reciprocity means in a two-port network, consider a two-port network. Okay, I will again consider the same two-port network. No, this is our two-port network, right? Two-port network, right? So this will be I1 and this will be V1, and this will be I2 and this will be V2, right? This will be V2. So simply V2. Okay. So if you applied a excitation V1, due to that there is a current I2. Okay, I already explained this. The ratio of the excitation to response is same. Then we can say that there is a reciprocity, right? What is the condition for reciprocity theorem says what? Reciprocity theorem says what? The ratio of the excitation to response will be always same, right? That means if you apply voltage V1 here and produce some output I2, if you apply simply a I2 here due to some voltage adjustment, if you apply some same value of I2 here, then the terminal voltage, suppose we measured using a voltmeter across this input terminal will be simply equal to the previous voltage. Did you get my point? Did you get my point? I will explain. That means if you apply some voltage here now, if you apply some voltage here, and there due to that there will be some current in the output section, that you know, right? There will be some current in the output section. Okay, and in the next case, you applied a V2 in the output section, so that the current here is same as that of the previous current, right? Response current, right? At that time, if you take a voltmeter and bring it here, and if you measure the terminal voltage here, it will be same as V1. That is another version of, another way of explaining reciprocity. In theoretical manner, we simply says what? V1 by I2 will be equal to what? V2 by I1, right? V2 by I1. This is one method of explaining, but the other method of explaining is this. If you apply the voltage here, due to that there is a current. If you apply voltage here and intend to flow the same value of current here, if you measure some voltage using voltmeter in the input terminal, that voltage will be same as that of the previous voltage. That is also a type of reciprocity theorem. That means in different manner we can explain that theorem, right? That's why. That means ratio of source excitation to response will be same. That's all. So how can we predict the circuit is reciprocal or not by using ABCD parameter? That is, if AD minus BC equal to 1, then we can say that then circuit is reciprocal. If AD minus BC equal to 1, that means A into D minus B into C bus. If it gives the value of 1, then we can say that the circuit is reciprocal. The circuit is reciprocal. Is it clear? Is it clear? Okay. So that's all about this ABCD parameter or transmission parameter and symmetry and reciprocity condition. Okay. So can we move to next session? Can we move to next session? Okay. So next is I think 4, right? 4, right? So hybrid parameter or H parameter, simply H parameter, hybrid parameter or H parameter. If a network satisfy this condition, then this is called the H parameters of the network. If a network satisfy this voltage equation or this metric equation, then we can say that the matrix, this matrix is called the H parameter matrix. This matrix is called the H parameter matrix. Okay, let's do how can we calculate this. Let's do how can we calculate this. Okay, let be V1 will be equal to, what is V1? H11 V2, right, plus H12 I1. Carefully you have to write this. Okay, H11 V2, H21 V2 plus H22 I1. Let be equation number 1 and 2, 3. Okay, so this can be right like V1 equal to something and V2 like this. No, simply I expanded the matrix, right? Simply I expanded the matrix. Okay, and how can we find that H11, H12, H21 and H22 all? See the RHS of the equation. What are the parameters here? V2 and I1, V2 and I1. Simply make once V2 equal to 0 and another time I1 equal to 0 bus. That's all. You will get the value of H11 and all H parameter. Okay, let's try that. First I am taking let when or simply when V2 is equal to 0. What is the meaning of V2 is equal to 0 means output is shorted, right? Some voltage equal to 0 means what beta? Output will be shorted, right? Output will be shorted. So when V2 is equal to 0, what happens here? It will be H12 is equal to V1 by I1, correct or wrong? That V1 by I1 will be in ohm, right? That will be in ohm, right? Because it is an impedance, right? And in next equation, when V2 is equal to 0 means H22 will be equal to what beta? H22 equal to 0. H22 means what? It is nothing but I2 by I1, correct or wrong? I2 by I1, which is no unit, right? Which is a unitless quantity, right? So that is the condition for V2 equal to 0. And next you have to make I1 is equal to 0. So when I1 equal to 0. I1 equal to 0 mean what is the meaning of I1 equal to 0? Input is open circuited. Correct or wrong beta? Input is open circuit is called the I1 equal to 0 condition, right? So when I1 equal to 0, what happens in this equation? We will have H11 will be equal to beta, H11 equal to V1 by V2, correct or wrong? And which is also unitless, correct? Or no unitless or no unit, right? And what is in the next equation when I1 equal to 0, it will give H21 will be equal to beta, H21 will be equal to I2 by what is that? I2 by V2, correct? I2 by V2. What is I by V means? It is nothing but what? Mho or admittance, right? Or simply you can say that it is MHO, mho or mho, correct? Correct. So now you have the values of what is no two unitless, no unitless or no unit quantities, two unitless or no unit quantities, that is H22 and H11, like ABCD, no, A and D were unitless, right? Similarly here also H11 and H2, that's principal diagonal elements, no, in matrix, that will be unitless, and other will be one O and other one will be mho, similar to that of ABCD parameter. ABCD, no, you discussed ABCD, no, where B is in ohm and C is in mho, right? Similar manner here also. and how can we represent it in a application manner. I mean, where this can be, H parameter can be applied. This have a very good application in transistor modeling. You know, whenever we dealing with what analog circuit, we will discuss more about this parameter where we can apply directly to the transistors. Whenever we define AC modeling of a transistor, there should some it is a very difficult session actually. We will discuss later in whenever we dealing with analog electronics. But as of now, we don't need that much, but we have to just know the peripheral idea. Okay, so how can we connect these in practical case or in what electronics, analog electronics case? I will explain. So this is a representation actually. Okay. See, this is the representation. Just note it. Just note it. Just note it. Just note it. See, this is the representation. This is the representation of a but H parameter or hybrid parameter. See, why the name hybrid means it contain but some unit and some unitless and some in ohm and some in mho, like that it contains, and also it contains the independent sources. When you represent it in a real circuit, it gives the independent source. I will explain. It's slightly difficult, I know, it's slightly difficult, but we will try to learn. See, by looking this side, what you get? V1 will be equal to, see, V1 will be equal to H11 V2, correct or not? H11 V2 plus H12 I1, correct? If the equation 2, no, these can be satisfied in the input side, right? What is V1 here? V1 is equal to H11 V2, that is H11 V2 plus H12 I1, because why this is in series means it is an impedance, right? H1 to see H1 is in ohm, right? So ohm into current will give the voltage itself directly. That is why it is in series representation. But in the output side, right? Output side, what is the equation for output, right? It is in I2 form, right? I2 will be equal to H21 V2. H21 V2 means H21 is in what? H21 is in admittance form. It is reversal or reciprocal of impedance, right? So if you multiply this with voltage, you will give the value of current, right? If you multiply admittance with what? Voltage, you will get the value of current now. So this is V2, right? This is V2. If you multiply this V2 with H21, V2 into H21, what is the value? What is the value of that? V2 into H21, what will give? See, this is V2 into H21 will give the value of this current, right? This current, right? Correct? And the remaining current, no, this current is nothing but what? Again, directly you have H22 I1, see, H22 I1. So H21 V2 will be nothing but a shunt current plus another current, that is a current source. H22 I1 is a current source, because H22 and H1 are unitless quantities, right? Unitless quantities means it is directly gives a source, it gives a source value. If you multiply H11 with V2, it will give a voltage source. If you multiply H22 with I1, it will give a current source. Bas kadam khali, bas. because H11 and H22 are unitless. If you multiply it with the voltage, it will give the voltage source. If you multiply it with the current, it will go the current source. Bus. Is it clear? For examinations, so competitive examination, no, this idea is more than enough, right? More than enough. Okay. Inbuilt, no, in depth concept and all, derivation and all, problems and all, we don't expect that type of questions, because it's not our area of concern actually. Okay, it is actually deeper analysis can be done by when we are dealing with the transistor and all. Deeper analysis can be done, but that also very more than efficient, like more than sufficient actually. Okay, so as of now, this you can just know about this. Okay, so this is V1, I1 and V2, I2. How can we connect it like a current source and a representation and all bus. Okay, so that's all about the H parameter. That's all about the H parameter. Okay, let's do one problem and more clarity will be there. Okay, write a question. A two-port network is defined by following pair of equation. Following pair of equations. Find the impedance parameter. Find the impedance parameter. Equation is nothing but I1 will be equal to okay. So this is our question. A two-port network is defined by following pair of equation. There are two equations connecting I1, V1, V2 and I2. Okay. So find the impedance parameter, right? Find the impedance parameter. So what do you mean by impedance parameter? It is nothing but Z parameter. So what was the basic structure of a Z parameter? It is nothing but what? Z parameter structure was V1, V2 equal to Z11, Z12, Z21, Z22, right? Into what is that? I1, I2. Correct or wrong? This is the structure of a Z parameter. That means the LHS side should be in V1 and V2 and the RHS will be, okay, it automatically comes, right? Z1 and I1, Z2 and I mean Z and I will be, or simply I can write like V is equal to I into Z. This is the structure of a what? Impedance parameter or Z parameter. Is our given equation or are our given equations are in this manner, V is equal to IZ manner? No. Our equations are in terms of I1 in the LHS, I mean I2 in the LHS. That means I equal to some voltages equation are there. So we have to convert this equation to V equal to IZ manner. Then we can directly find the value of Z matrix or impedance matrix. That is our aim. Is it clear? So how can we do that? How can we find the equation like V equal to IZ manner or V equal to IZ format? How can we arrange the equation in order to get the V is equal to IZ format? Okay, let's try. Suppose I am doing 1 minus 2 here. What I get? I1 minus I2 will be equal to, when I am doing 1 minus 2, I1 minus I2 will be given 2V1 plus V2 minus of V1 plus V2. Correct or wrong? It will simply 2V1 minus V1 is nothing but V1. V2 and V2 get cancelled. So I1 minus I2 will be equal to what? V1. I1 minus I2 is equal to what beta? V1. So now you got V1 equal to some I condition, right? Some I condition, right? Okay. Means our aim is in LHS should be V1. That means arrange this equation 1 and 2 in terms of V1 equal to something, V2 equal to something. Bus. That's all. Arrange this equation in terms of V1 equal to something, V2 equal to something. Bus. that definitely give the answer. Okay, let's try. So I1, first one minus 2 will give the I1 minus I2 equal to V1. Okay, and what will be your next step? So you got V1 right, so V2 also we need, right? V2 equal to something also we need in order to solve this question. So how can we do that? How can we do that? Listen. So if I multiply second equation, right? Second equation with the 2, equation 2 with the 2 into 2 minus 1. If I do this, what I get? 2 into 2 means 2i2 equal to 2v1 plus 2v2. Correct or wrong, beta? Correct or wrong? 2v1 plus 2v2. Correct? 2v1 plus 2v2 and minus this is for this is now, and minus, okay, minus what is 1 here? I1 equal to, beta, I1 equal to 2v1 plus v2. Correct? Correct? If you subtract this from this, what I get? 2i2 minus I1 will be equal to, change the sign, right? This and this get cancelled. It is simply 2v2 minus v2 is nothing but v2. Correct? 2v2 minus v2 is nothing but v2. That means you have now v2 is equal to minus I1 plus 2i2. Correct or wrong, beta? Correct or wrong? So now in your hand you have two equations connecting v1 equal to something and v2 equal to something. If this satisfy v is equal to iz format, then what will be z1 1, z1 2, z2 1 and z2 2? Can you tell me that? Can you tell me that? I can write like, see, v1 equation, no? v1 is equal to what? z11 I1 plus z12 I2, no? See, what is v1 here? z11 I1 plus z12 I2, no? So if you have v1 equal to I1 minus I2 means I can write, so I can give this equation as 3, okay, and this as 4, right? This as 4. From 3 and 4, okay, simultaneously you can write from 3 and 4. Z11 from 3, Z11 will be 1, Z12 will be minus 1, Z21 will be minus 1, Z22 will be 2. Correct or wrong, madam? Correct or wrong? From this, it is in the form of Z11 I1 minus Z12 I2. So Z12 will be minus 1, Z1 will be 1. This is also in the form of V2 equal to Z21 I1 plus Z22 I2, right? So V2 will be equal to Z21 I1. So Z21 will be minus 1, right? Minus 1, and Z22 I2. Z22 means 2 buts. So I can write my Z matrix as, find the impedance parameter, no? So the Z matrix will be, or the impedance parameter will be, or Z parameter will be what? 1, minus 1 and 2. So can you tell me this is what? Symmetric network. Is it symmetric or not, beta? If A equal to D only, we can say that symmetry. So it is not symmetric. And check for the reciprocity. AD minus BC equal to 1. Is it correct? 2 minus AD minus BC equal to 1. No, correct, right? 2 this is into 2. 2 minus this one, minus 1 into minus 1 plus 1. So 2 minus 1 will be equal to what? 1. So this is actually a reciprocal network, but not a symmetric network bus. Okay, if you find that out, that also you can make that conclusion. Okay, so that's all about that question, basic question. So did you note it? Did you note it? Is there any doubt? You can ask. Okay, if you have any doubt in my classes, please mention in the comment section, then only I can answer. And if you have any trouble with my presentation or my explanation or my way of teaching, okay, you can tell me. If possible, if it is convenient to me also, then I will change my style also. Okay, don't worry about that. If it is style in the sense it is too fast or it is very too low or a sluggish, no, sometimes it's very lagging, no, if you feel like that, you can tell me directly, I will change. Okay, because it's all for you, right? It's all for you, because no, I already told my motive, right? I already told you my motive. So it's all for you. So if you are telling, sir, this you can change, then it will be better, then I will change. Okay. Actually, I consider you as my family. Okay. This is our family of field electricals at the right angle is my family, right? It's my family. I consider this is my family. Okay. So you can tell me whatever you feel. Okay. I will change. So let's do another question. Let's do another question. Write a question. For the given network, find Z matrix. For the given two-port network, find Z matrix. See, in the examination, this type of question will be asked. This type of question will be asked. 1 or 2 line answer will be maximum 80 to 90% of the question will be one liner question. You can answer within 1 or 2 steps, you can answer that. That type of question will be 80 to 90%. Remaining 10 to 15% or 10 to 20% will be difficult question. But if you crack it as one line question, you will definitely get the job, because cutoff will be nearly 70 range, right? More than 70 will not, no cutoff will be there in any examination. I hope so. More than 70 is very good mark actually. Okay, so maximum 75 you can expect, maximum. In Kerala syllabus, in Kerala PSC and all, last year, 3 years back now, sub-engineer were there, and sub-engineer exam, for sub-engineer exam, 48 or 49 or 45 I think was the cutoff. For electrical inspectors 50 was the cutoff, right? Out of 100 you have to simply score 50. Yes, you will get the job. Okay, so that was the condition, but now it may be slightly increased by 1 or 2 marks or 5 marks maximum, not beyond that. Okay, so for the given question, find the Z matrix. It's very easy actually, because we already mentioned that Z matrix can be easily solved by, or Z parameter can be easily solved by what? T network, right? T network. And Y parameter can be easily solved by pi network. This should be always in your mind. Okay, so you can directly tell this. What is the Z matrix here? Z. What is the Z here? Z is nothing but Z11, Z12, Z21 and Z22. This is right. This is right. And it is nothing but, what is Z11 here? Add this to 60. What is Z12 here? Simply the shunt branch 40. This is Z21 is same as the shunt branch 40. Z22 is nothing but add this to 100. Bus. This is the answer. This is the answer. Okay. So that's all about the that question. Okay. Write another question. Write another question. Write another question. Okay. For the given two-port network, find Z matrix again. Find Z matrix. Okay. Right. Okay. How can we find the value of set matrix again? So you may have a doubt that this is not exactly in the form of T, right? This is not exactly in the form of T, right? Because no branch is here, right? No impedance is here, right? So you may feel that it is not in the form of T, or we have to search for another some methods. No. If you don't see any impedance here, you simply put the value 0 bus. You simply put the value 0 here bus. No need to overthink and all, right? So what will be Z11 beta? So impedance matrix will be Z11 will be what? Directly you can write, like directly you can write. We are expert now, right? So directly you can write. Z11 will be, add these two, right? So it will be 2, and Z12 will be simply this, and Z21 is also simply this. Z2 is simply add these two. Yes. That's all about the set matrix. That's all about the set matrix. Okay? Did you get it? Did you get it? Okay? You have any doubt? Do you have any doubt, my dears? Do you have any doubt, my dears? No, right? So write another question. Write another question. Find the short circuit parameter for given network. Find the short circuit parameter for the given network. Given network. Yes. Find the short circuit parameter for the given network bus. Short circuit parameter is nothing but beta. What is that? Y is the short circuit parameter, right? Admittance parameter, right? It is nothing but beta Y11, Y12, Y21, Y22, right? That is the admittance matrix, right? This is the admittance matrix. This is the admittance matrix, correct? So we have to find the admittance matrix from this network. So we learned that admittance matrix or Y matrix can be easily solved by what? Pi network, right? Easily solved by pi network. There is no change in that. This is the pi network, right? This is also pi network. So oh Bhagwan, thank God, right? But those admittances were, this was Y1, this was Y2, and this is Y3, right? Initially in your original figure, no, when I took that Y admittance matrix class, the original figure was Y1, Y2 and Y3, no? Did you remember that? Yes. This is Y1, Y2, Y3. That is also, or that was also in mho or ohm raised to -1, or in admittance, right? Or in admittance form. See here, this is in admittance form? No. This is in what? It is in ohm or impedance form. So can you directly go for admittance matrix now? No, it will be wrong. First you have to convert this impedance to admittance. Then only you will get the admittance matrix, right? Then only you will get the admittance matrix. Okay, so I can write like Y11 will be equal to what was the equation for Y11? Y1 plus Y2, correct? When it was Y1, it is Y1 plus Y2, but it is not in Y1 form. Y11 will be Y1 plus Y2. I will write like this, but Y1 is nothing but 1 by this one, correct? Okay, that is 1 by 0.2, correct or wrong, better? Correct. Plus 1 by 0.2, correct? So what will be this? What will be the answer? 1 by 0.2 is nothing, pi, and this is 2. 7 mho, right? Or ohm raised to -1. 7 mho or mho raised to minus 1. So you go to y11. What is y12 beta? Y12 is nothing but minus y2, correct or not? Minus y2, minus y2. So minus y2, which is nothing but minus 1 by 0.5. So it is nothing but minus 2 mho. And what is y21, which is also minus y2, which is equal to minus 2 mho. And what is y22, which is nothing but add these two, right? y2 plus y3, which is nothing but 1 by 0.5 plus 1 by 0.2, which is nothing but 2 plus 5 is okay, 7 more. So our admittance matrix will be finally, what will be our admittance matrix beta? What will be our admittance matrix? I can write here. Admittance matrix will be y is equal to what? Y is equal to 7 minus 2 minus 2. So this is a symmetrical matrix, right? A equal to D, no? Here also, right? We can, if it is in ABCD, not in here. If it is in ABCD, we can say that is a symmetric network. Okay. ABCD only we can say that is in symmetric. In the previous problem also, if you have a Z matrix, we can't say that symmetric or reciprocity is there. Okay. If I made a mistake there, really sorry for that. We can't judge it from Z matrix. We can only judge it from ABCD matrix only. Okay. ABCD matrix only we can judge that whether it is in reciprocal, where it is in symmetric network. Okay. We can't judge that from any other parameters, whether it is Z or whether it is Y, whether it is of H parameter. No, we can't predict from that. We can predict only from ABCD parameter. Okay. If I made a mistake there in previous problem, like I told you, no, okay, this is equal, this can be considered AD minus BC equal to 1. I said no, it is only applicable for ABCD, not for all parameters, right? Okay. So now for the answer to our question, find the short circuit parameters in nothing but 7 minus 2 to minus 2 7. Okay, that is the answer. Did you get that? Did you get that better? Okay. So that's all about the two-port network. That's basic of two-port network. Okay. Can you follow my classes? Can you follow my classes? Can you follow my classes? Next, you have to see another important session, which is nothing but basic functions of electrical or electronics. Basic functions. Basic functions. Okay. You can remove this because it's not any two-port network. Basic function. First, you have to see step function. First, you have to see step function. A step function is represented by that means f of t will be equal to u of t for t greater than 0 and 0 for t less than 0. So this is called the step function. So step function means it's simply a DC signal. After t equal to 0 or when t greater than 0, that step function will arise like it having a constant magnitude of u of t with infinity time, no, up to time ends or up to its battery fully discharged. This is nothing but the output current or output voltage of a DC battery, right? So a DC source or DC battery source can be considered as a step function. Why you have to learn this basic function means in electrical engineering as well as electronics engineering, we have to analyze the circuit by applying many of the possible input signal. That signal may be ramp, that signal may be parabola, that signal may be unit step, that signal may be input impulse, light impulse, no? That type of signal will be there. So what is the advantage of knowing the response of such signals, no? In real practical cases, no? In real practical cases, any one format or the combination of these signals will be actually what? Impact on the circuit, actually hit on the circuit. So we have to pre-judge, we have to already judge what happens when we apply some certain type of input to a system, certain type of signal to a system. What will be its output? We have to already predict, we have to already know. Then only we can put that circuit into practical application. See, for example, of impulse is nothing but lightning. Lightning is considered to be like an impulse wave. That means it exists for very short duration of time and it vanishes. So it is considered to be likely to be considered as an impulse wave. So only by knowing the property of the system for the impulse signal, when that circuit is actually you put it in practical, or actually you place that circuit in real atmosphere, environment, if suddenly a lightning strike on the circuit, then you can predict its output or its response. Clear? Then only you can clearly study the system. That is the meaning of studying this basic function. That's why we have to study this function. Clear? So these all are actually available in the nature itself, actually available in practical cases. Clear? I already told you, no, this step function is nothing but charging. I mean, simply you take a battery, no, dry cell, you simply connect a bulb across its terminal. That will be a step function. There will form a step function. That means the voltage, if you draw the voltage across it with a time, you will definitely get this. You will definitely get this step function. Clear? So that is the indication. So first you have to see the step function. So u of t, that is the value will be f of t, that is function value. Function value will be u of t for t greater than 0 and 0 for t less than 0. Very important thing is that at t equal to 0, what is the function value? At t equal to 0, what is the value of function? It's very, very important. For a graph like this, it starts from 0 and it ends in u of t now. So at t equal to 0, the value of the function is, you can't see here, no? What is actually at t equal to 0? You can't see here. What is actually at t equal to 0? What is the value of the function? Array, what is that? You can't see. You can't see. But the answer is, it is nothing but u of t plus 0 by 2. That is how it arrived u of t plus 0 by 2. How it obtained? How can I obtain this? It is nothing but the initial value minus final value divided by 2. The average of this length is the average of this changing. If a function is changing or if something is changing, how can we find the average? No? How can we find the average? If you simply add the initial plus final divided by 2, no? That is the average, right? So in similar manner, here it is very difficult to directly by our eyes we can't find what is u of t, but using mathematics we can find that. That is nothing but initial minus final divided by 2, u of t plus 0 by 2. That is the value of the signal at t equal to 0. It's very, very important. It's very, very important. Very, very important. That is the concept of step function. And next is nothing but unit step. Unit step. Simple. Suppose the step function f of t having a value of 1 for t greater than 0, that is f of t equal to 1 for t greater than 0 and 0 for t less than 0. And what is t equal to 0? Its value. For what it will be? T is equal to 0. It is nothing but 0 plus 1 by 2. That's all. 0 plus 1 by 2 at is equal to 0. If this is this manner, if you represent a signal, that is called the unit step function. Nothing but magnitude 1 beta. Magnitude 1. Next we have to see a ramped function. Ramp function. That means if a function is represented by f of t equal to at for t greater than or equal to 0 and 0 for t less than 0 is called the ramp function. Ramp function. So ramp function means if a signal is represented by f of t equal to at t greater than or equal to 0 and for 0 it is t less than 0, then it is called a ramp function. This a is nothing but beta slope, because this is the equation of a straight line like now y is equal to mx. This is in the form of y is equal to mx, right? So m is nothing but slope, that is nothing but r, a, that is nothing but a, and this is r of t will be equal to at. This is correct actually. This is correct. This will be in the form of y, that is r of t, that is a signal, right? F of t or r of t equal to a into t. A is nothing but slope, t is nothing but time axis, nothing. Okay, bus. That is y is equal to mx. So m is the slope. Okay. So if you have a signal of 5 into r of t means, what is the meaning? Slope is equal to 5. If you have a signal 10 into r of t means slope is equal to what? 10 bus. Slope is equal to 10 bus. Is it clear? Is it clear? This is very important. It's very important. Okay. So that's all about the ramp function. And for unit ramp it is nothing but instead of this a it will be 1, right? Instead of a it will be 1, that's all unit ramp. So that means f of t will be equal to simply t, that is the concept of unit ramp. Unit ramp means slope is equal to 1, right? Unit ramp means if r of t is equal to t means it is called the unit ramp, which is nothing but slope of that will be equal to 1. Which is nothing but slope of that will be equal to 1 beta. Slope of that will be equal to 1. Is it clear? Next very important function is called impulse function. Impulse function. Impulse function is represented by del of t, and that del of t will be equal to, its value will be equal to beta, listen carefully, infinity at t equal to 0 and 0 for t not equal to 0. T not equal to 0. Del of t will be equal to infinity for t equal to 0 and 0 for t not equal to 0. That means that impulse function, no, it only exists for t is equal to 0. For remaining all the time interval, its value will be 0. That's how I already explained. Transients, no transients. Transients means some waves which is appeared for very short duration is called as transients in electrical system. So transients are considered to be likely to be, it is like an impulse waveform. Therefore, acting it for very short duration and vanish after that, and it will vanish after that. So that is called the impulse function. I will explain more about this impulse function, how that obtained and all. Okay. That means why that infinity, meaning of that infinity, no, del of t is equal to infinity for t equal to 0 and 0 for t not equal to 0, I will explain now. So there is a property of impulse, very important property of impulse is that minus infinity to infinity, integral minus infinity to infinity, del of t dt equal to 1. Integral minus infinity to infinity, del of t dt will be equal to 1. The meaning is that del of t dt, integration means nothing, del of t dt is nothing but area, right? Area of the curve, right? Impulse signal is nothing but a signal having, suppose a signal have width equal to, suppose it is 10 raised to minus 15 and height will be equal to 10 raised to 15. then the area will be equal to what? 10 raised to 15 into 10 raised to minus 15 is equal to 1. Or in other words, if some signal having width is equal to 10 raised to 100 minus 100 and height is equal to 10 raised to 100, then what is its area? 1. That is the meaning of impulse signal. If a signal exists having very high height, infinite duration height, no, this one is for area, right? This one is representing the area, not the magnitude of the signal. Magnitude of the signal is infinity. In practical case, infinity means very high height. At a t equal to 0, its amplitude will be very high, beta. Its amplitude will be very high. Or its area will be very what? Area is always 1, no? Its amplitude will be very high. Its amplitude will be very high. That is the meaning. So if you have height is equal to 10 raised to 100 means in up to infinite, no, nearly up to infinity, no, and correspondingly width will be 10 raised to 100. That means a small width to high height spike, no, that is considered to be the impulse function. That is considered to be the impulse function. A short width, high height function. A short width, high height function is considered to be the impulse function. Then the area will be equal to what? The area will be equal to 1. The area will be equal to 1. If you have 10 into del of t means area equal to 10. If you have 5 into del of t means it implies, or it also implies, area of the function will be equal to 5. Very, very important. Very, very important. Like that, r of t will be 5 into r of t means slope, no? 10 into del of t means area of the curve. Area. 10 represents the area. That means this impulse having an area of 10. Area of 10. Area of 10. Clear? That's all. And okay, that's all. So this is all about the impulse function. Let's check the time now. Okay, time is up. So and you know what is one more thing. See, 5 into u of t means what? Its amplitude is 5, right? 10 into u of t means what? Amplitude is 10. This you should be take care of this. So for a unit step function, the what value near to this function is representing the magnitude. For ramp function, it represents the slope. For unit, impulse function, it represents the area. It represents the area, correct? Okay, so that's all about today class. So let's meet again tomorrow. So until then, bye and take care. Okay, thank you so much.